Okay, here's the second clip, and you may come across the term a fault thrower. Switch. And there's our transformer again. And we've got live. I'm showing single phases here all the time to keep it simple, don't forget. Live and neutral, don't forget that's earthed at this end. And a fault thrower switch is effectively a special switch that's put on the circuit, and it has a bit of a dummy load there, and I'll put the switch down here. I forgot, I should have put it there really, but I'll put it here. And that's going down to earth. And it's normally to test a circuit breaker, which is usually in the substation. So the fault thrower switch will test the circuit breaker from a distance away from the substation. So that's what a fault thrower switch is for. So there's our circuit breaker inside the substation, and there's our fault thrower switch remote from the substation. Okay. It acts a little bit like the button on an RCD in your consumer unit. The test button does a similar sort of thing, really. Okay. You remember from our video on earthing, there is our link, there is our fuse, and there is our appliance, and there is our circuit there. Now in a TT situation, which is terra, where we need electrodes, you remember we have an electrode at the consumer end. So here is our electrode down here, stuck in the ground, and we have an electrode, of course, back at the substation or the transformer on the pole. Now, this resistance path here, from here to here through the ground, has to be as low as possible. And if it's too high, you can lower it by putting extra electrodes into the ground at either end, creating more parallel paths, which lowers the resistance. So we have to have a low resistance between those 2 points, because it causes the fuse or circuit breaker to operate fast, and that's why that has to be a low resistance path. So you might get questions on what's the important thing about these 2 electrode points, and the idea is that the resistance path has to be as low as possible. Okay. Transformer windings. The winding of a transformer, because it's tightly wound around the core, the insulation on this winding coil has to be very thin, and the thinnest way to do that is to use varnish. It's actually it's now a plastic, a very fine plastic film that they use on the winding, but it's very, very thin. Traditionally, it was what we call a varnish, but it's not like a wood varnish. It's a bit more sophisticated than that. It's specially developed to have high insulation properties. It's got a very high dielectric strength when it dries on the winding. You could use rubber, or you could use PVC, but it'd be too thick. The thinner the varnish is, the more tightly packed you can have the windings, and they're very close together. Because the winding itself must be insulated, because if it wasn't insulated, it would just be a solid lump of copper, and it wouldn't function as a winding. It would just function as a piece of wire going from A to B. So varnish is the preferred insulator on transformers. Okay. When the electricity leaves the substation, there's our substation again, live and neutral. When it leaves the substation, your control room needs to be able to monitor how much electricity is actually leaving the leaving the substation. So you have to measure the current, and that's done by putting a little current coil in series with that, like that. And you can have another current coil acting like a transformer, and that will go back to your control center monitoring the current. Similarly, if you wanted to measure the voltage, you would have a voltage coil across the live and neutral, and a transformer would measure voltage across that as well. Now these days, these two figures, voltage and current, would be measured electronically and digitally converted back to data to send back to your control room. But they still need this effective transformation methodology to get that information. So a current and a voltage transformer are used to measure current and voltage leaving your substation to your customers. That needs to be monitored. Okay. What else have we got? The oil in a transformer. There's your transformer, and it's full of oil. There's a tap usually on the outside that you can take a sample, and the test that's used to test the moisture content of the oil is called a crackle test. And the crackle test, what they do effectively is heat up a sample of oil and test whether it spits and crackles to see whether there's any moisture in it.